This call is now being recorded. Now this shield grounding is a mechanism which is in place because in spite of taking care in the previous part, whatever we discussed, still we have some capacitive effects, especially at higher frequencies. So the parallel grounding or single point grounding, all these things, they are dependent on frequency. Especially for high frequency circuits, multiple ground points are preferred to single point grounding because a lower ground impedance is obtained if you make use of multiple grounding. So multiple ground helps in reducing the impedance. Now to further overcome these high frequency issues, what is done is another mechanism known as shield grounding is adopted. Now what is this shield grounding? Usually what is done is a part of the conductor, if it is a long wire or something, part of that conductor is shielded with another conductor or covered with another conductor, and this conductor is, or the shield is, maintained at some reference potential. Now by maintaining this at some reference potential or constant potential, the current which is flowing through this shield is made to flow through this reference and through that to the ground. This has several advantages because a constant low current is made to flow, and any excess leakage current or the voltages which are produced due to the capacitive effect between the conductors is minimized by this kind of a shield grounding. Whenever shielding is used for amplifiers or any other blocks, say instrumentation amplifier or a sensor block, they are always maintained at some reference potential, and that in turn is grounded. Here you can see few circuits used for shielding. Now in the first circuit, you just see here, there is an instrumentation or general amplifier we'll consider for the time being. Here 1 is the input and 3 is the output, and this is one reference. Now this point is connected and the outer rectangular block is nothing but a shield. By doing this shielding, between these two conductors there is a capacitance developed, and between these two there is another capacitance developed. Now this point is grounded, and this point which is grounded, this is the circuit ground, that is grounded to the shield. Shield is the outer part. So this point and these two are grounded. So this is the correct way of shielding. The shield and the circuit ground, they are maintained at the same reference potential. So this is the correct way of grounding. Now the next one is here the same circuit. If the shield is not connected to ground properly, then what happens? Here these conductors are connected to ground, but the shield is not at all connected to this common ground. Now what happens due to this? Between a shield and each one of the conductor, there is a capacitance getting developed. So between shield and ground, there is no direct connection. As a result, each one of these conductors can produce a capacitance, which in turn may affect your further readings. Now here how many capacitors are getting developed? Between the second conductor and shield, there is this capacitance C2S. Between the first conductor and shield, there is one more capacitance C1S. And between the third one and the shield, there are these three capacitors are coming into picture. Now, if you connect them in the circuit form, you can see that the capacitance C1S and C2S, they are connected with one common terminal like this. And between this conductor and shield, again this capacitor C2S is connected. So the connection or the capacitive effect or the capacitors are formed between the shield and the circuit like this. Now instead of minimizing the effect of these capacitors by using the shield, we are adding these capacitors to the measurement system. So if simply shield is connected and not properly grounded, it adds to the errors in the measurement system. So properly always shield has to be grounded. Now what is the proper way to shield, to ground it? So one way is the simple, this and this they have to be connected. The second way is, if the circuit is too big or the shield is too big, only one ground may not be sufficient. So what is done is, here one ground and this one more ground here, and these two in turn are again connected to the same potential point. Otherwise, between these 2 points, there may be some voltage like this, Vi, which is going to be produced. This voltage, when it is produced, it is going to again disturb the system. So if the circuit is big or if the shield is big, only one ground is not sufficient. Many grounds, which in turn are connected to one another to maintain common potential, have to be used. Now see in the next circuit. So this is the analysis of this circuit. Now what is happening here? There is a Vi voltage which is coming in with C1S. Here you can see. So one more capacitance C1S which is connected here between this and this is one ground. So this ground and this ground, assuming them to be common, between the shield and this, there is this capacitance, there is another capacitance here. So these two are coming in picture here. So these are the two capacitors. Now the next capacitor C3S is connected between the output terminal here, between the output terminal and the shield. So this is the capacitance which is connected here, output terminal and the shield. So the output terminal here and the shield, there is this capacitance coming, and this is what is shown here, C3, yes. Now the second capacitance C2S, which is coming between the shield and the ground. The shield and the ground here, this capacitance between shield and ground. If the value of this capacitance is small, even then it should be grounded. If the value of the capacitance is small, just because of that, if you leave it open, this again produces the spurious signals. So at no point of time in such circuits, ground connections should not be kept open. They should always have proper connection. Simply if the small values, thinking that they may not have any effect on the final output, it is not so. These capacitors, in turn, if they are kept open, they produce the voltages with another conductor here. They form the capacitance with another conductor over here if not grounded properly. So always this kind of a proper grounding to minimize these effects If need arises, multiple ground connections, which in turn are grounded to one another, have to be used. And here, this this voltage VI, if it is not grounded properly, see here it is grounded, but the C2S is kept open. By keeping the C2S open, only one end is connected here to the shield, and that too, that shield is not grounded. Here, this ground is different and this ground is different. So between them only there is a potential getting developed. And if this C2 is connected, one end is connected here, the other end is not connected, this causes this voltage VI, which is produced across this. Now this VI comes into picture, and by doing this VI, by connecting this VI like this again, whatever input comes here to the input end of the instrumentation amplifier is going to be influenced by these two capacitors. So if the circuit ground is not proper, or if it is not done, grounding is not done properly, it does not solve the issue of spurious voltage production or the interference voltages which are produced due to capacitor formation or capacitive coupling. So they have to be taken care properly. So this is regarding the grounding and shielding to prevent the capacitive, inductive and resistive interferences.